Good morning. My name is Monica Aragues. I'm quite sure that among the audience there are people from several countries. In this session entitled HVDC Grids, we also have people from several countries among the speakers. Muhammad Raza, he's from Pakistan, and Afsaneh Sol, she is from Iran, and Eduardo Prieto and me, the last ones, we are local people. Okay, what's the general outline for this session? First, we will have a brief introduction to HVDC grids. We will have an overlook to the future of short network and its grid integration. We will analyze how to control MsC HVDC multi-terminal systems. We will also have a look at how to control an offshore load connected to a multi-terminal MsC HVDC system. And finally, we will see if we can optimally operate HVDC grids. Okay, let's start. So, the first question that arises is, what is a DC grid, no? It's an electrical grid based on DC current that can operate independent of one or several disturbances. So it means that it must have fault isolation capability. Yes? And what is a DC supergrid? It's obviously a larger scale DC grid. But the concept is that it can integrate large amounts of renewable energy. It can transmit them across long distances, and it can connect several grids that don't need to be in the same country or in the same continent. This is like my view. Let's see another definition, the one from Friends of the Supergrid, that it's an association that is working towards the construction of a supergrid in Europe. And for them it's like an electricity transmission system mainly based on direct current, designed to facilitate large-scale sustainable power generation in remote areas for transmission to centers of consumption, one of whose fundamental attributes will be the enhancement of market in electricity. From these concepts, you can already guess which is the motivation for HVDC grids. The distribution of renewable sources in the different zones of the Earth is such that in the north of Africa we have a lot of solar power from which we can profit. We have offshore wind in the North Sea, and we have big amounts of hydropower in Northern Europe. HVDC could enable the grid integration of all these sources. It also will help to change generation patterns. We can see that, for example, in Germany and other countries are already working for closing nuclear power plants. And furthermore, this could also help to the interconnections of different countries. So, HVDC seems quite suitable for long-distance bulk transmission generation. It enables low losses, and it can have less environmental impact. Regardless of which kind of HVDC connections we have, if we focus on the HVDC application for transmitting the power from a wind farm or an offshore wind farm, we will for sure have some key elements. We will have, of course, the wind farm grid. We will have to adapt the voltage level through transformers. We will have to adapt the electrical nature of the power we are transmitting. We'll have converters, and among the transformers and converters, we will need filters due to the high amount of voltage or current harmonics we have due to the commutations of the switching elements. Then we will have the transmission, which will be one or several HVDC links, and again we will have transformers, converters, and filters, and another converter station, and the AC grid to which we are connected. Which kind of connection topologies we find for HVDC? we have one or two offshore wind farms, like we can see in this slide, we can transmit the power from each single wind farm to the main grid through a single HVDC cable. In this case, we have for each wind farm an HVDC point-to-point connection. Another type of configuration would be to interconnect through the DC side of the DC converters of the converter stations the two wind farms. This will be the radial connection. And why not adding certain redundancy and forming this HVDC grid or the meshed configuration, so that if we lose one of these DC links, for example, this one or this one, we can still transmit the power to the grid. Okay? So the most complex HVDC system we will have is multi-terminal. And it's even more complex if it's meshed. Does the HVDC is it only interesting for offshore wind farm interconnections to the mainland? The answer is no. We can find many different applications. Of course, one of the most known is the offshore wind connections. In this case, in this picture, you can see the first HVDC link to transmit offshore wind was built in Germany, and it's the HVDC Borwind 1. You already know the interest of offshore wind in let's say, or in the installation of wind farms in offshore sites. You can build obviously larger wind turbines. Their profiles are smoother, and in principle you have less social opposition. Another application for HVDC, the interconnection of grids. You can also do this using AC technology, but in some cases HVDC it's not an option but the solution. For example, in Japan, a part of this country works at 50 Hz and the other part works at 60 Hz. So the HVDC configuration called back-to-back, which means that the two converter stations are not distant from each other, enables to transmit power to two grids that are asynchronous, which means that they are working at different frequencies. Another application of HVDC is to, as in feed, to cities that are high densely populated. This is the example of the cross-sound cable, and it's in the States, and it serves as interconnection between New England, and Long Island. Its power rating is 330 megawatts, and the voltage level is plus minus 150 kilovolts, so it's bipolar. It's in total 300 kilovolts, and it's 40 kilometers, and it's buried on the sealand, on the seabed. Finally, the other application I would like to mention for HVDC is to connect remote generation. That's the case of a very recent project in India, where the city of Agra, in the north of India, receives power, specifically hydropower, from the northeast of India through a ultra-high voltage DC system. Why ultra-high voltage? This is how they call HVDC that reaches even higher levels that they consider as high voltage typically. It's an example of plus minus 800 kilovolts, and it's a huge distance. It's more than 1,500 kilometers, and it will enable, it's not still finished, the idea is that it will be a multi-terminal system. It will enable 8 gigawatts power transfer. So, looking at all these applications and at all these projects, it seems that HVDC has a promising future, but some challenges still remain. Are we going to build HVDC point-to-point? Are we going to build multi-terminal systems? Probably we first start by point-to-point, and then we progress towards multi-terminal. But there are issues like protections and groundings. There are issues like which converter technology are we going to use? Are we going to merge it appropriately with the AC existing system? We have to also take into account regulatory issues, also the efficient and secure operation of the system, and how to control the power flows in all these HVDC systems, or even in the HVDC system. To try to solve or give answers to some of these challenges, we have many speakers here today. So now I will give the floor to Muhammad Raza.